Okay, now this question is related to the wave. So let us read what this says. So easy one. So this says a person sitting at a distance of 10 meters from a source of sound of power W naught. So there is a sound source here is given. So there is a sound source. Let us call it S. And there is a person that is sitting 10 meters. So person is sitting somewhere here. So 10 meters at a distance of 10 meters there is a person sitting. Now it says the source power is W naught. So this means energy emitted by the source per second is W naught. And the person writes the wave equation, the wave received by him. So wave equation written by the person is y is equals to E sine 20 pi x plus 7000 pi t. So this is the wave equation written by the person. So first part asks, determine the density of air. So we have to find rho air. So first part asks what is the density of the air. If the bulk modulus of the air is, and is given, bulk modulus of air is 1.4 into 10 to the power 5 Newton per meter square. So now if we remember, velocity is given by, so if I have a velocity expression, this is generally v by under root p by rho. So now rho is given. So v is given. Velocity in air is something b by rho, bulk modulus divided by density. Now we know the density, we know the b, we can find the rho. So let us put the value of b here. So if I put the value of b and velocity, so first find out the velocity. So what is the velocity? Velocity is, this is omega, this term is k, this is omega. So we know velocity is, so velocity, let us put velocity is given by omega by k. So omega by k is velocity. Omega is 7000 pi and k is 20 pi. So pi cancels off, this comes out to be, let us write here, so this is 350 meter per second. So if you see this one, 700 by 2, that is 350 meter per second. So now if I write this velocity here, so if I use this velocity, that is 350 is equals to under root b by rho. B is 1.4 into 10 to the power 5 and rho I have to find it out. So let us square both sides, and if I write rho is equals to 1.4 into 10 to the power 5 divided by 350 raised to the power 2. Now if I calculate using the calculator, now this value will come out to 1.14. So this value 1.14 kg per meter cube. You also have to check, and if the answer is not coming, please contact me. Okay, next part. So part B asks, so this question has two parts. So part B is also easy. This says if the largest pressure amplitude tolerable by the human ear is 28 Pascal. So P maximum that a human can, the person that is sitting at a 10 meter distance can tolerate a pressure maximum of 28 Pascal. This is also given, 28 Pascal, that is the maximum pressure this person can tolerate. Now then determine the maximum power W naught. So what is this maximum power W naught? So that the maximum power W naught of sound source and displacement amplitude of waves received by the him. And now displacement amplitude also we have to find a displacement amplitude. What is the displacement? So these are both by the person. So what is the displacement amplitude that is received by the person? So this is received by person. So let us think, how will you do? Do you remember there is a relationship between pressure and intensity? And many people does not remember this equation, but this equation is very important. And intensity is given as, so this, try to remember this equation. P naught square by 2 rho B. This expression is important. So you have to remember this expression, P naught square by 2 rho B. Now we know the rho, we know the B, and then we can calculate P naught. So if I put this value here, so P naught is 28, so this is given P maximum, so this is P max, that is 28 Pascal, so 28 square divided by 2, and rho is also given. We have already calculated 1.14 kg per meter cube in the first part, so this is rho is 1.14, and velocity is 350. We have already calculated in the first part, so velocity is 350. Now if we solve this all, 1 2 3 4, this comes out to be 1 2 3 4 watt. What a good number, 1 2 3 4. Now see, we have calculated the pressure amplitude, the amplitude, good, the pressure amplitude, that is maximum. We have to find it out, and we have to find the W naught. So this we have calculated intensity at a distance 10 meter, that is received by the person, because this pressure amplitude received by the person, so this means this intensity is received by the person. So maximum intensity, if I have a sound source, this emits the energy. So at a 10 meter distance, I can write intensity is total power emitted by this is W, and this cross-sectional area is 4 pi r square. So intensity at 10 meter is given by W naught by 4 pi r square. This is the intensity. Now we know the intensity, we know the 4 pi and r, so we can calculate the W naught. So if you see intensity, we have calculated 1 2 3 4 is equals to W naught divided by 4 pi, and r we know this is at 10 meter distance, so 10 square. Now if we calculate this from here, I can calculate what is the value of W naught. This value comes out to 1 2 3 4. This value comes out to be 0.982. So this value is 0.982 watt per meter square. Check it out. This value is 0.982. So this value is 0.982. Now if I solve this here, then I will get in the watt, W is equals to 982 into 4 pi into 100. Let me check using the calculator, because calculation is important. So if I use the calculator, so this value, so 982.982 into 4 into pi into 100, and this value comes out to 1 2 3 4. So what is 1 2 3 4 watt? So this is the power of source. Now we have to find amplitude also. Now we can find amplitude using this expression. Amplitude is given by P naught by rho V W. Now amplitude is given by this, and now we know the P naught, we know the rho V W, so we can calculate. This expression is easy. If you remember, P naught is A rho B omega. If you remember, pressure of P naught is BAK, something like this. P max is BAK, and if you plug the value of B and K, will get the answer. B is what? B is, so velocity is B by under root B by rho. So you can write B is V square into rho. B square into rho. This is the B into A, and K is nothing but omega by B. So this comes out to V rho A omega. So this is the expression V A rho omega. Now this expression is not tough expression. You have to remember. Now P naught is A rho B omega. P naught is 28 watt, and A we have to find it out, and rho we know. Rho is in the first part. This is we have already said 1.14 kg per meter cube. You see here, this value is 1.14 kg per meter cube, this value. So if I plug this value 1.14, and velocity I have already calculated, this is 350. Omega already we know, this is 7000 pi. Now from here I can calculate what is the value of A. So this comes out to be, so let me do calculation, 28 and divided by 1.14 divided by 350 divided by 7000 and then divided by pi. So amplitude comes out to be 3.19 into 10 to the power minus 6, 3.19 into 10 to the power minus 6 meters. So this amplitude is so small. So this is a very small amplitude. So this is a amplitude of the wave that is received by the person. So you see, in this question the important part is, so 2-3 point is important. One important part is intensity is, so many people does not remember, intensity is P naught square by 2 rho V. This expression you have to remember. Intensity is equals to pressure naught square divided by 2 rho V. And the second important point is, by a point source, intensity at a distance r is given by W by 4 pi. This is something like Gauss law. If you have a charge here, intensity or electric field here, Q by 4 pi epsilon naught r square. Same thing. Now this time we have a W naught power here. W naught, this is the wattage here. This is not power. This is the total energy. Even you can define in terms of total power also, because energy crossing per unit time is power. Energy crossing per unit time per unit area is intensity, and total crossing energy is called simply energy or wattage of the source. So in this case, the second important point is intensity is given by W naught by 4 pi r square by a point source. If you have a line source, intensity simply becomes, so let us say W is the energy crossing per unit time. So this becomes W naught by 2 pi r L. If it's given, if the length of the source is L, so this total area will be 2 pi r into L. So I have a source of length L, so this is the length of source, and energy crossing total is W naught per unit time. So this becomes W naught, so this is the total energy per unit time, and total area is 2 pi r into L, so 2 pi W, so W naught by 2 pi L. Total energy is 2 pi r L into I, intensity into area is equals to W naught. So here I is equals to W naught by 2 pi r L. Important point also, there is no energy that is radiating from this phase, upper phase, and there is no energy radiating from the bottom phase. You can see for a line source, energy emitting in something like this, and this will be a circular cross section. In this way, no energy from the top, no energy. So if you see the cross section, circular cross section, it will look something like this. Now the second point, one more important point, amplitude, basically pressure maximum is given by BAK. This expression you have to remember. And now you can transform this expression and it will come rho V omega A, and this is the pressure amplitude expression. Now amplitude, pressure amplitude we know, so we can find out the amplitude of the wave. This is important point. Okay, we'll discuss next problem.